Good day viewers, welcome to my YouTube channel. So in this video, we'll wrap up our substructure measurement. We have two items left to be measured, our starter column and our oversight concrete, or we call it concrete slab. So before we commence measurement, I want us to confirm the size and the numbers of column we have on our plan. So from the column section and from the schedule here, we have three different types of column: CT1, CT2, and CS. CT1, we have 16 numbers of CT1, we have two numbers of CT2, and two numbers of CS. Then the next column here, it shows the location, or let me say, position or location of those columns in the building. So this particular column, it's starting from the from the first floor to roof. But this particular column starts from the ground floor to the first floor, while the last column here, it starts from the ground floor to roof level. Since what we want to measure is starter column, what's required here is those column that are starting from the ground floor, which is CT1 and CT2. So from the schedule, we have 16 numbers of CT1 and two numbers of CT2, making 18 altogether. But before we commence measurement, I want us to reconfirm the numbers of column from our foundation layout plan. So this is our foundation layout plan. I will confirm the numbers of column we have on this plan with the aid of count 2. One, two, three, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we have 18 numbers of column. So let's quickly measure that. So we have two plugins here for measuring column. The first one is meant for rectangular column, while the other one is for circular column. As well know, our column can be in two forms, either it's rectangular or square, or it's circle. So if your column is rectangle in shape or square in shape, you can make use of this plugin. While if it's circle, you use this other plugin to measure your column. Okay, so the number of column here is 18. The thickness of the column is 0.25, while the width of the column is 0.25. So what's left here is the length of the column. So I'm going to trace the length of the column from the column section. That means I have to, I have to switch to the other drawing. Okay, let's reactivate that. Wait. Okay, so what I have to do here is just trace the height of the column right from this section. Right from the section. I can make use of any of the section since they are all the same. Okay, let's make use of this. But since I'm coming, let's reconfirm the dimension. This is 0.63. think the drawings are now to scale. Wow. So I'll have to rescale this drawing. Let me delete this and rescale. Because according to what we have on this drawing, this distance from this point to this point should be 900 and not 800 and something. So let me rescale this. This will be 1.4. 1.4. Let me reduce the text height. Okay. 0.2. Then let's reconfirm that dimension. Okay, I think the scaling is correct now. So back to our plugin. Back to our plugin. What I'm going to do is just trace the distance from this point down to this point. Then I click on escape. So with that, I'm done with measurement of concrete in starter column. So we have other items there that are yet to be measured. Our reinforcement in column, the link, and the formwork. So let's check the size of reinforcement. So from this section, so the size of reinforcement from the section is 16, and from this section we have four numbers of reinforcement in our column. Four numbers from this section. The size is 16. So the size of our reinforcement here will be 16. The bar width for 16 mm is 1.577. The numbers of column is 18, while the numbers of straight bar here is 4 because we have 4 bars in our starter column. The projection upward here is 150 from this point to this point. It's 150. So if you add this into it, the thickness of the oversized concrete, which is also 150, so then we will have 300 mm as the value of our projection, 0.3. While the bend, I think we have to assume something. The bend is the distance from this point to this point. Distance from this point to this point. Our projection should also include the distance from this point to this point. Distance from this point. So what should that be? Let's assume 152. So that means we have 150, 150, and distance from this point to this point to assumed as 150. That will be 450. So this, let's change this to 450. 0.45. While our bend, let's assume 150. 0.15. You can actually use your dimension tool to trace that distance. Dimension tool to trace that distance, but let's just assume 150. So the next item of work to measure there is the link. I believe we all know what links are. So the number of column is 18. The diameter of our link, I'm coming. Let's look for that part that shows the details of the link. Um, okay, this is it. We have 6 numbers T10. So the size of our link is 10 mm, while the type of reinforcement here is T. So numbers of column 18, the diameter is 10 mm, then the bar width is 0.616. The spacing, the spacing, okay, the spacing here is 175 mm, 175, 175. While the numbers of side B is 2, the number of side A is also 2. Because if you look at what we have here, is a square. The shape of the column is a perfect square. So if this side is side A, this other side here will also be side A. So that means we have 2 side A. And if this is side B, this other side will also be side B. So we have 2 side A and 2 side B. So that's why I inputted 2 here, and I also inputted 2 here. Then the length of our side A, according to our section here, is 230, while the length of side B is also 230. According to what we have in the section, it's 225. I think they approximated the dimension here to be 230, but the actual dimension, according to what we have in our column section, is 225 by 225. So I'll input 225, 225, 0.225. The value of our hook, or the length of our hook, we'll just have to assume that it's not given in the section. So let's make use of 150. Then the cover, 25 mm, and the numbers of cover is 2, because we have cover to this side of the reinforcement and the other side of the reinforcement. The distance between the link itself and the external part of the column is the cover. Distance between the external part of the column and the link, that's the cover. And we have 2 of that. We have 2, 1 here to this side, and we also have 1 to this other side. So we have 2 covers. And with that, we are done with measurement of link. The last item under our starter column is the formwork. And what this is asking is just the numbers of, what it's asking for is just the numbers of column, which is 18. So the last item is our oversized concrete, our concrete slab. We also have a plugin here for concrete slab. This plugin is meant for concrete slab. So we're going to measure our concrete slab on our foundation layout plan. So let's switch to that plan. Okay, this is it. This is our foundation layout plan. Our oversized concrete, our concrete slab, is to cover the whole starter column we have here. This part here is the column base, while the thick thick black um thick black spot here is our starter column, that way. So our oversized concrete, our concrete slab, will cover the whole starter column. So let's activate our, okay, before then, let's cross check the thickness of our oversized concrete. Okay, according to this section, the thickness of our concrete slab is 150 mm according to this section. Let's go back to our foundation layout plan. So I'm going to activate this by clicking on the green button here. Okay, so the thickness is 150, which is 0.15. Okay, so we trace the whole external parts of our starter column. down that way. I think this is the last sticker column. So with this, we are done with measurement of our oversized concrete. So as you can see here, we have the total volume of concrete. So be 18.70, while the formwork here is 49.50. 49.50. The thickness of the oversized concrete is 150 mm, which is less than 500, and according to BSMM 4R, once the height of the concrete work is less than 500 mm, the formwork will be measured in meter and not meter square. So I'm going to delete this. So with that, we are done with measurement of substructure work. In our next video, we'll start with measurement of superstructure work. Thanks for watching.